So, good morning. And welcome everybody to this third day, day 3 of the Desert Song Festival Country and Climate Yarning Circle. It's great to see so many people out here this morning. My name's John Wiseman and I work at Melbourne Climate Futures at the University of Melbourne. I'd like to begin by acknowledging that we are on Arrante country and to pay my respects to elders past, present and emerging. So let's get started, and first up to talk about climate change trends, both observed and in the future in the Northern Territory, is Professor David Karoly. And David is an internationally recognised as a world leader in climate change science. He was leader of the Earth Systems and Climate Change Hub in the National Environmental Science Program between 2018 and 2021. He's a climate counsellor and a fellow of the Australian Academy of Science. On a more personal note, he has at times been described as the scariest person at the University of Melbourne for the very powerful way in which he communicates scientific evidence about climate change trends and impacts. But I'm sure, as you'll see, David combines scariness with a range of hopeful messages as well. So, David, we look forward to your presentation. Thank you.
Thank you, John. And when I talk to my grandchildren and read stories to them, they don't find me scary. So, however, the story that I've got to tell you this morning is a pretty scary message, although I hope that I can finish, as John encourages me to do every time, to finish on a positive note. And there are things that we can do to address climate change. But what I'm going to do is, in fact, try to cover the stuff. But the other part is I often perform for the audience, and I will come away from the lectern. I won't always come away from the lectern, but what I'm wearing is one of the best indicators in the Australian ecosystems of sensitivity to climate change. And if you wanted me to tell you what it is afterwards, but not now. No, you have to wait for the yarning session, because I listen very carefully to what the session chair says. But that also means I've got a very limited amount of time, and I'm going to race through a lot of stuff. What I'm presenting is based on a publicly available report that was prepared by the research hub that I was leading, the National Environmental Science Program, Earth Systems and Climate Change Hub, prepared for the Northern Territory government in 2020 on climate change in the Northern Territory. It's publicly available. The website is in the references at the end, and we will share this presentation to all the people that have registered. So I'm going to start with the long-term variations. This shows the carbon dioxide concentrations in the lower curve over the last 2,000 years from air bubbles trapped in ice cores from Antarctica, then combined with carbon dioxide concentrations from air collected in Cape Grim, in Western Tasmania, and I've just forgotten Kananook in the northwest of Tasmania. This shows that the carbon dioxide concentration was essentially much the same, around 280 parts per million, for essentially until the Industrial Revolution, and then it rose exponentially, and concentrations now are higher than they've been for more than 2 million years. Concentrations, even though this says past 400, they've now passed 410 parts per million, still rising rapidly. That's important, and really, really important. But a whole bunch of strange people say that this is just due to natural variability, and it's due to underwater volcanoes, or it's due to the temperatures causing more carbon dioxide coming out of the oceans. The other graphic, the one that shows the exponential drop in carbon dioxide ratio of carbon dioxide carbon-13 to carbon dioxide with the carbon-12 carbon isotope. That ratio is indicative of photosynthetically processed carbon dioxide. Photosynthetically processed is what is carbon is in fossil fuels, because fossil fuels are made up of plant material that's been compressed to make oil or gas or coal more than 60 million years ago. Or it's due to land clearing and cutting down trees. That exponential drop in the carbon-13 to carbon-12 ratio shows that all the carbon dioxide that's been added to the atmosphere is photosynthetically processed carbon dioxide from burning fossil fuels and from land clearing, not any other process, and proves that it's due to human activity over the last 150 years. That's why that graphic, which almost everyone hasn't seen before here in the audience, is so important. We are the cause, as that little video said already. So, well, what has that done? It's caused a warming of the climate system, an increase in global temperatures, yes, with year-to-year natural variability, but we're now at 1.2 degrees Celsius above pre-industrial levels. As I said, this set of presentations will be made available to anyone who's registered and showing up. So you don't have to take photos. You're welcome to. I prefer them to be of me than of the slides, but that's okay. I'm modest. Where are we heading? Well, that's going to be a really important question, but I'm going to show where we are now in the Northern Territory. This is the Northern Territory temperatures. Oh, well, okay, we'll come back to the last slide in a second. You can see that the year-to-year variability in the Northern Territory is much larger than the year-to-year variability in the previous slide. Year-to-year temperature variations plus minus about at 1 to 2/10 of a degree, mainly due to El Nino and La Nina events. When we're in the Northern Territory, the year-to-year variability is as much as 1 degree Celsius because it's a smaller region. If you go to Alice Springs, the year-to-year variability in temperatures can be 2 degrees different on average in 1 year relative to the previous year. But let's look long-term. What have we seen long-term? It's gone up from about minus 0.7 of a degree relative to the base period, 61 to 1990, up to more than 1 degree. That means the warming in the Northern Territory is 1.7 degrees. Question for the audience, rhetorical question. Why is the Northern Territory warmed much more than the global average? And it's not because Northern Territory is hotter than the global average. It's because the Northern Territory is land. Land warms up faster than the global average because the global average is 2/3 ocean, 1/3 land. Land heats up faster than the ocean. Why do we talk about global average temperatures when most people are not fish and live on land? We know that the warming on land is going to be about 50% higher than the global average. When we talk globally about trying to limit global warming to 2 degrees, that's 3 degrees on land. Have you ever heard of anyone talk about the global agreements to limit global land temperatures? Now they will, but it's not 2 degrees, it's 3 degrees or 1.5 degrees, which is 2 1/4. What does this mean for extreme temperatures? This graph only goes up to 2019 because the report was released in 2020. It's the increase in daily record temperatures and the number of days that are in the top 1%. How many days are in 1% of days in a year? 3.65. What are we up to in terms of the number of days above the 1 percentile in temperature? Well, in 2019, it looks like we were at 40 days, 10 times the expected number. Everywhere in the Northern Territory was really hot. What's happened to rainfall? Well, this is the 20-year average rainfall for the most recent decade from the State of the Climate report produced by the Bureau of Meteorology and CSIRO. There's a new one coming out at the end of this year. Shows that the rainfall in the wet season, October to April, averaged over the last 20 years in the northern part of Australia is at record high levels. Rainfall has been increasing in Northern Australia, particularly in the wet season. If we look at the dry season, the winter season, actually, Rainfall hasn't changed much in that season, maybe decreased a little bit in Alice Springs. But if we look in southern Australia, that's where there's been big declines in wintertime rainfall. I'm not going to show that graphic, even though a significant fraction of the population, the audience lives in southeastern and southwestern Australia. I'm not going to show that one because I'm focusing on the Northern Territory. What about the future? We use complex mathematical models of the climate system globally to simulate future climate with increases in greenhouse gases included. How good are they? Well, this shows climate model projections from those global climate models, climate simulations for the projections into the future that were released in 2015 and how they compare with the observed changes for temperature across northern Australia. You can see the large year-to-year variability of temperatures, but you can also see the 20-year average temperature trend showing this marked warming we've had. It does show 2019 in that graphic. Yes, 2019 was the hottest year across northern Australia, but you can also see that that warming trend is entirely consistent with the observed projections released back in 2015 and for the period starting in 1995. You can also see what's projected for the future. There's no projection of a global ice age about to start next year. It's projections of further warming due to the greenhouse gases that are in the atmosphere already. So what do we know is going to happen? Warming is going to continue and get worse, and there are going to be more temperature extremes. What about rainfall? Well, the good news is that we don't actually know what's going to happen to rainfall, but it's likely in the climate projections. Yes, there's going to be continued large year-to-year variability, but we expect there to be no long-term rainfall trend for the average rainfall. I need to speed up because I've almost run out of time. What about Alice Springs? We're in Alice Springs at present. If we look at temperature change, and there was a presentation yesterday afternoon by Supriya, she looked at Alice Springs temperatures. If we look at mean temperatures in Alice Springs, yes, they've increased significantly, about 0.6 of a degree. We're already most of the way to the projected temperatures for the most recent decade, 2011 to 2020. The last 10 years is already at 2030s temperatures. What about extremes? We've actually experienced temperature extremes, number of days over 35 or number of days over 40 Celsius, which are at the 2030s projections. Unfortunately, the 2011 to 2020 is tracking at the worst case for 2030 climate projections. And Supriya said yesterday, well, actually, if you look only at a short period, 2018, 2019, and 2020, that is at the 2050s in extreme temperatures in Alice Springs projections. Now, that's a short period, we know, and actually the extremes have been a little bit less in Alice Springs for 2021 and 2020. Not as bad as 2018 and 2019. What about the projections all across Australia? Well, look, I don't have time to go around all of these. What's relevant for the Northern Territory? I'm going to start at 1 o'clock on this in the dial. Fewer tropical cyclones. That's good news. The only problem is the ones that occur are likely to be more intense. That's the bad news. Cool season rainfall is expected to decline in southeastern and southwestern Australia, as it has over the last decade. Heavy rainfall extremes are likely to get more intense because warmer temperatures mean more moisture in the atmosphere, and when it rains, it gets heavier. Hotter temperatures and more evaporation on land, particularly in dry years, leads to worse fire seasons all across Australia in dry years. I've talked about the increase in heat waves. Heat waves also impact the oceans. We get more ocean heat waves that will impact coral reefs in the northern part of Australia. Sea level is already rising and will continue to rise, not just for the next 100 years, for the next 500 years due to the warming we've had already. Well, what's expected to happen to global temperatures? Where are we heading? The good news is we can make choices now, we and the rest of the world, about what climate they would like to achieve by reducing greenhouse gas emissions. We have a choice between limiting global warming to only 1.5 degrees, although we're likely to shoot through that and then we have to recover, draw it down, or warming as high as 4 degrees globally, 6 degrees in Australia. Because remember, Northern Territory and Australian temperatures on land are 50% higher than the global average. What do we need to do? Currently, global emissions of carbon dioxide are 40 billion tonnes per year. Where do we need to go? Well, if we want to limit to only 1.5 degrees to reduce global temperatures when they hit 2 degrees in 2050, to then reduce them, we have to go to net negative global emissions at 10 billion tonnes per year. That's tough. Otherwise, we can only limit global warming to 2 degrees. But if we don't act now or 10 years ago, we're likely to get global warming of 3 degrees or more. But there are opportunities that we can take. The climate of the past is not a good indicator. We need to understand that climate change is changing the weather and climate systems everywhere. We need to make choices associated with a hotter climate and more variable rainfall. We need to seize the opportunities of storing more carbon in soils, of planting more trees, as well as the opportunities for the Northern Territory, particularly in Alice Springs, around using solar power. And that's what we're going to hear more about this afternoon. We also need to understand that the climate change, some of it is locked in, and there will be major impacts of climate change already occurring, and they're going to get worse. Seize on the opportunities and adapt to climate change. There is a whole set of references. I'm going to skip through them. John, I'm done. Unfortunately, the climate is done too.